Welcome to Thermodynamics lecture series. In the present lecture, we will discuss the example problems on temperature scale and thermometer. Let's see the problem. On a new scale of temperature called W scale, the freezing and boiling points of water are 39 degree W and 239 degree W respectively. What will be the temperature on the new scale corresponding to a temperature of 39 degrees Celsius? Let's see the solution. In the previous lecture, we determined the relationship between the Celsius scale and the Fahrenheit scale. So same principle we are applying for this problem also. So first we have to determine the relation between the Celsius scale and the W scale. For this, observe the data. In the data, it is given that freezing point of the water is 39 degree W on the W scale and boiling point of the water is 239 degree W on the W scale. And we know that freezing point of water on the Celsius scale is the 0 and boiling point of water on the Celsius scale is the 100. Let's consider here capital C is the Celsius scale and capital W is the W scale. Similarly, Tc is the temperature on the Celsius scale and Tw is the temperature on the W scale. So next we have to subtract the 39 from the W scale which align its 0 point with Celsius scale. So Tc equal to Tw minus 39. Then we are dividing the 100 for the Celsius scale which gives the Celsius scale per degree. Similarly, dividing 200 for W scale which gives the W scale per degree. Then equation will become the Tc divided by 100 equal to Tw minus 39 divided by 200. From this equation we can be written as Tc equal to Tw minus 39 divided by 2. And in the data it is given that what will be the temperature on the new scale. So have to determine the Tw. Corresponding temperature of the 39 degrees Celsius. So Tc is the 39. Then have to determine the Tw. So substitute here Tc equal to 39 degree. Then Tw will become the 39 equal to Tw minus 39 divided by 2, which will become the 2 into 39, that is the 78 equal to Tw minus 39. Then Tw equal to 78 plus 39, it is the 117 degree W. So our answer is the option D is correct one. So this problem is given in the UP TGT Science in the 2019. Let's see the another problem. In a new temperature scale, say degree P, the boiling and freezing points of water at one atmosphere are 100 degree P and 300 degree P respectively. The reading of 0 degree P on the centigrade scale is. Same principle here also we are applying. So here it is given the freezing point of the water is 300 and boiling point of the water on the P scale is 100. And we know that freezing point of water on the Celsius scale is the 0 and boiling point of the water is the 100. Then Tc equal to Tp minus 300. Then we have to divide it. Tc divided by 100 equal to Tp minus 300 divided by 100 minus 300. It is the minus 200. Then Tc equal to Tp minus 300 divided by 2. And here we have to determine the reading of, on P scale it is given 0 degrees. Then we have to determine the TC, temperature on the Celsius scale we have to determine. So Tp equal to the 0. Then we have to determine the Tc. Then we have to substitute Tc equal to the 0. Then Tc equal to minus 300 divided by minus 2. It is the 150 degrees Celsius. So option D is correct. So next we have to see the another question. Which of the following property is used as thermometric property in constant volume gas thermometer? Option A, volume. Option B, pressure. Option C, electric resistance. Option D, voltage. This problem is given in APPSC polytechnic lecture exam in 2020. So in the previous lectures we discussed the basic principle and details of the constant volume gas thermometer. The basic principle of the constant volume gas thermometer is, at constant volume, so pressure is directly proportional to the temperature. So if the change in temperature, so pressure also it will be changes. Some thermometric property is the property which is changes with respect to the temperature. So here for this given question, option B, pressure is the correct answer. So next we have to see the another question. The thermometric property X of a thermometer varies with temperature T according to the relation T equal to AX square plus B, where T is in degrees Celsius, X is in centimeter, and A and B are the constants. At ice point, that is 0 degrees Celsius, and steam point, that is 100 degrees Celsius, the values of X is 5 centimeter and 20 centimeter respectively. When this thermometer is brought in contact with a heated body, the value of X is recorded as 15 centimeter. Then the temperature of the heat body in degrees Celsius is. So let's see the solution. Here given the relation is for the temperature and the thermometric property, that is T and the X, that is T equal to AX square plus B. Here T is the temperature in degrees Celsius, X is the thermometric property in centimeter, A and B are the constants which are to be determined. And observe the data. Here it is given that one the ice point and steam point, and the values on the degree Celsius is, so in the degree Celsius temperature of the ice point is the 0 and steam point is the 100, and corresponding thermometric property, that is the X. So X values is given, so X is the 5 at 0 degrees Celsius and X is the 20 at 100 degrees Celsius. Then we have to determine the temperature of the heated body in degrees Celsius. Let's consider small t. And it is recorded that thermometric property at heated body is 15 centimeter. Okay, let's see the solution. So here given the relationship is the T equal to AX square plus B. So first we have to observe this relation at the ice point temperature. At the ice point temperature is the 0, so T is the 0, and corresponding thermometric property, that is the X, is the 5. So relation will become the 0 equal to A into 5 square plus B. Then it will become the 0 equal to 25 A plus B. Let's consider this is the equation 1. Similarly, we determine the relation at the steam point. Then relation will become the Steam point temperature is 100, so small t equal to the 100, and thermometric property is at steam point is 20, then x is the 20. Then substitute t and x values in the t equal to ax square plus b equation. Then 100 equal to a into 20 square plus b. Then it will become the 100 equal to 400a plus b. So let's consider the two equations. First one is the 0 plus 25a plus b equal to, let's considering the equation 1, and similarly another equation 100 equal to 400a plus b. This is the equation 2. So by observing these two equations, we will be determining the two constants. So for this, subtract the first equation from the second equation. So that is second equation 100 equal to 400a plus b, and first equation is the 0 equal to 25a plus b. Then subtract this one, 100 equal to 400a minus 25a, it is the 375a, and b minus b, so b is the cancel. So from this one, a equal to 100 divided by 375, which will become the 4 divided by 15. Then substitute this a value in the equation 1, we will get the b value. So equation 1 is the 0 equal to 25a plus b, then substitute a is the 4 by 50. Then equation will become the 0 equal to 25 into 4 by 15 plus b. So here, so 5 3s and 5 5s. So then the b will become the minus 20 divided by 3. We know the a value and the b value. Then we have to determine the temperature of heated body, and corresponding x value is the 50. So let us observe in the equation t equal to ax square plus b. Here x value we know, that is the 15, and a value we know, and b also we know. Then substitute all the values in the t equal to ax square plus b. Then t equal to, so a, that is the 4 by 15 into x square, that is 15 square, plus b is the minus 20 by 3. So here 15 and 15 will get cancelled. 4 into the 15, that is the 60. So t equal to the 60 minus 20 by 3. So here LCM will become the 3, and so 3 into 6, it is the 180. 180 minus 20, so it is the 160 divided by 3. So temperature is the 160 divided by 3, which is nearly equal to the 53.33 degree Celsius. So this is the solution. And next we have to see the another problem. A platinum resistance thermometer has a resistance of 2.8 ohm at 0 degree Celsius and 3.8 ohm at 100 degree Celsius. Calculate the temperature when the resistance indicated is 5.8 ohm. So here it is given the resistance of the platinum wire is the 2.8 at 0 degree Celsius. So R0 equal to resistance at 0 degree Celsius, that value is the 2.8 ohm. Similarly, it is given the 3.8 ohm at 100 degree Celsius. So it is the R100 when the temperature is 100 degree Celsius, that is resistance at 100 degree Celsius is given 3.8 ohm. And T is the temperature in degree Celsius. We have to calculate temperature, that is the small t we have to calculate when the resistance is indicated 5.8 ohm. So RT, resistance at T temperature is 5.8 ohm. So first we have to determine the alpha, and we know the linear relationship between the resistance and temperature for a platinum resistance thermometer is RT equal to R naught into 1 plus alpha T. Here alpha is the temperature coefficient of resistance. So relation is RT equal to R naught into 1 plus alpha T. So here in the data it is given R100, that is the 3.8 ohm, and T is the 100 degree Celsius. R100 means resistance at 100 degree Celsius. Then small t will become the 100, and R0 resistance at 0 degree Celsius is the 2.8. Then substitute these values here. RT place you have to substitute R100. Respected value is the 3.8. So resistance at 300 degrees Celsius is the 3.8. RT is the 3.8. And R0 is the resistance at 0 degrees Celsius, that is the 2.8. And 1 plus alpha T. So equation will become the 3.8 equal to 2.8 into alpha into 100. So then this equation will become the 3.8 equal to 2.8 into 2.8 100 alpha, which is the 280 alpha. So equation is the 3.8 equal to 2.8 plus 280 alpha. Then here it will become the 280 alpha equal to 3.8 minus 2.8, which is the 1. So 1 equal to 280 alpha, and alpha equal to 1 divided by 280, which is equal to alpha equal to 0.003571 degree Celsius to the power minus 1. So next we have to determine the, so temperature we have to determine, T we have to determine, and resistance at T temperature, that is the RT, is 5.8 ohm. So RT value we know, R0 value we know, alpha also we know. Then we have to determine the T value. Then here RT value will become the 5.8. So resistance at T temperature. So RT equal to the 5.8, R0 is the 2.8, and 1 plus alpha value is the 0.003571 into T. So it will become the, so 5.8 divided by 2.8 equal to 1 plus 0.003571 into T. So which is equal to the 5 by 8 divided by 2.8, it is the 2.071428571 equal to the 1 plus 0.003571 T. From this equation, T will become the 300 degrees Celsius. So this is the solution, and this question is given in the engineering service exam for electronics paper in 2011. So thank you.